Alright, before we finish in this section working with greatest common factor, this last example here looks at using the greatest common factor of numbers to solve a problem. Right? This situation is somebody has 3 different piles of coins, 3 different types, and they want to group them so that they can make as many groups as possible and have the same number of coin in each group, and there's no leftovers. Alright, and they have 18 toonies, 30 loonies, 48 quarters. So, the first question is here, what's the maximum number of groups they can make? Maximum number of groups they can make. Well, they could split them up, just so we understand this first here, they could split it up so that, 9 of each of those go into each group, and 15 of each of these go into each group, and so that, 24 of each of those go into each group, but that's only 2 groups, right? The question here is, what's the most number of groups you can make? What's the maximum number of groups? Well, what you want to know is, what's the biggest number you can divide each of these things by and not have a remainder, right? What's the biggest number you can divide them by evenly? And that is, by definition, what the greatest common factor is. So, find the greatest common factor of those 3 numbers, and that's your answer. Now, there's 2 different ways that you can find greatest common factor. One is, again, just list the factors of each of those 3 numbers. So method number 1 here is going to be just make a list of factors of each of those numbers. For 18 it's 1, 2, 3, 6, 9, and 18. For 30 it's 1, 2, 3, 5, 6, 10, 15, 30. And for 48 there's a lot of them. 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. Those are all the factors of those numbers. Now, if you're looking for the greatest common factor, well, let's look at what all the common factors are. 1, 2, 3, and 6 are what they all have in common. 1, 2, 3, and 6 are factors of all 3 of those numbers. So then, by definition, the greatest common factor is the biggest one of those, which is 6. So, maximum number of groups you can make is 6. Now, you could also find this by our other method that we were using here, which was break each one down into its prime factors, right? 18, if you break it down to prime factors, again, just look what you can divide it by. You can divide it by 2, and you get 9. You can divide that by 3, and you get 3. And you can divide that by 3, and you get 1. So its prime factors are this, right? 2 times 3 times 3 gives you 18. You can do the other 2 as well, right? 30, you can divide it by 2, you get 15. You can divide that by, you can't divide it by 2, but you can divide it by 3, and you get 5. You can divide that by 5, and you get 1. And you're down to those are your prime factors there. Last one, 48. Divided by 2, you get 24. You can divide it by 2 again, you get 12. You can divide it by 2 again, you get 6. Keep dividing it by 2 until you can't anymore. You get 3. Divide that by 3, you get 1. So those are its prime factors. Now, once you have the list of prime factors, you can come up with this 6, the greatest common factor, by just looking at the prime factor they have in common. They all have a 2 in common, right? They all have at least 1, 2, and they all have at least 1, 3. So the greatest common factor then has to be 2 times 3, or 6. So if we're going to actually answer that, what we should do is, we should say, even though I have no room here, we should say maximum of 6 groups. Alright? Now the next question is, how many coins are going to be in each group? Well, if you had 18, 30, and 48, you're going to have, if you divide each of those by 6, you're going to have 3 toonies. You are going to have, just make sure I got that right there. Yes. You're going to have 5 loonies. And you're going to have 8 quarters in each group. And then the last part of this problem asks, how much will each group be worth? Well, you know how much each of those is worth, right? I'll just do it up here. We'll write it up there. 3 toonies times $2, or $6. $6 in toonies. Or 5 loonies, which is, don't even have to write the multiplication here, but $5, right? $1 coins in loonies. And 8 quarters times 25 cents, you're going to have $2 in quarters. All right, so that is that problem. Using the greatest common factor to solve a problem. All right.